For centuries, humanity has looked up at the night sky and wondered if we are alone. Could life exist beyond Earth? Could we live elsewhere? Among the planets in our solar system, Mars stands out as the most promising candidate for exploration and potential settlement. But what makes this cold, dusty world so captivating? Mars is the most Earth-like planet nearby. It has polar ice caps, seasons caused by its tilted axis, towering volcanoes like Olympus Mons, the tallest volcano in the solar system, and vast canyons such as Valles Marineris. Signs of ancient rivers and dried lake beds suggest that liquid water once flowed on its surface. Its atmosphere is thin, about 1% of Earth's pressure, mostly carbon dioxide, which poses challenges but is far more manageable compared to Venus's crushing atmosphere or the gas giants. The travel time to Mars ranges from 6 to 9 months using current rocket technology, making it feasible for human missions. Beyond these practical reasons, Mars holds a deep emotional and symbolic allure. It represents human curiosity and the drive to explore new frontiers, a beacon of hope and adventure. Colonizing Mars offers humanity a potential survival strategy, a backup for our species if Earth faces catastrophic risks. It also pushes us to expand our technological, social, and philosophical boundaries. Becoming a multi-planetary species is a bold step in the story of humanity. Mars isn't just a distant world, it's the next great adventure waiting just beyond the horizon. Mars is a planet of extremes, with an environment that is both fascinating and hostile to human life. Despite its similarities to Earth, the Martian environment challenges everything we know about survival. Its atmosphere is less than 1% of Earth's pressure and consists mainly of carbon dioxide. Humans cannot breathe this air without life support systems, meaning that any colony must rely on airtight habitats or spacesuits. Every breath of oxygen needs to be carefully recycled and managed to keep people alive. Temperatures on Mars are brutally cold, averaging around -80 degrees Fahrenheit, -62 degrees Celsius. Nights and polar winters can plunge far colder, colder even than Earth's coldest regions. Maintaining warmth requires advanced insulation and efficient heating systems, as exposure to the cold could be deadly. Radiation presents another invisible but serious hazard. Mars lacks a global magnetic field and has a thin atmosphere, so cosmic rays and solar radiation constantly bombard its surface. Without proper shielding, this radiation can increase cancer risks and damage DNA. Habitats may need to be built underground or covered with layers of Martian soil to provide protection. Gravity on Mars is only 38% of Earth's, which might cause long-term health issues such as muscle atrophy and bone density loss. We still do not fully understand how humans will adapt to this lower gravity over months or years. Living on Mars demands not only advanced technology but also resilience and adaptability to overcome its harsh environment. Landing safely on Mars is only the first step in establishing a permanent human presence. Thriving on the red planet means building habitats that protect inhabitants and harnessing local resources to support life. Martian habitats must be airtight and pressurized to protect from the thin, toxic atmosphere and extreme temperature fluctuations. They must also shield residents from harmful radiation. Early designs often include inflatable domes reinforced with Martian soil or underground bases carved from lava tubes. These structures require reliable life support systems that provide breathable air, clean water, temperature control, and waste recycling, essentially a closed-loop ecosystem. Transporting all necessary materials from Earth would be prohibitively expensive. This is where in situ resource utilization becomes vital. Mars soil, or regolith, contains abundant materials that could be used to build structures, make bricks, or even 3D print habitat components. Technologies like NASA's MOXIE experiment are already showing how to extract oxygen from carbon dioxide in the atmosphere, which is essential for both breathing and rocket fuel. Water is critical for human survival, and can be harvested from underground ice deposits and hydrated minerals. However, Martian soil contains perchlorates, toxic chemicals that must be removed before growing crops. Hydroponic and aeroponic farming techniques growing plants without soil are promising solutions. Scientists are experimenting with crops like potatoes, lettuce, and algae that could provide food, oxygen, and recycling benefits. Solar power will be the primary energy source, but Mars receives only 43% of Earth's sunlight. This limitation means nuclear power might be necessary to provide continuous, reliable energy. Successfully building a self-sustaining habitat on Mars requires creativity, innovation, and a careful balance between technology and nature. Terraforming Mars, the idea of transforming it into a warm, Earth-like world capable of supporting life, is one of the most ambitious concepts humanity has imagined. While fascinating, it remains a monumental scientific challenge. Mars is currently a cold desert, with an average surface temperature near -60 degrees Celsius, and an atmosphere less than 1% of Earth's pressure. The atmosphere is almost entirely carbon dioxide, but too thin to sustain liquid water on the surface. Without adequate pressure, water rapidly boils away or freezes, making life impossible without protective habitats. To terraform Mars, scientists propose releasing greenhouse gases such as perfluorocarbons to trap heat and thicken the atmosphere. Some speculative ideas include deploying giant orbital mirrors to reflect additional sunlight or redirecting asteroids to impact Mars, releasing energy and gases. Another challenge is that Mars may lack sufficient carbon dioxide and other volatiles in its soil or ice caps to build a thick atmosphere. Even if atmospheric pressure could be increased, oxygen levels would remain too low for humans to breathe. Introducing oxygen would require engineered microbes or machines to generate it over centuries or millennia. Terraforming Mars is a massive, multi-generational project, part science, part hope, that tests our creativity and patience. For now, living inside protected habitats remains the most realistic path forward. Living on Mars is not only a technological challenge but also a profound human experiment. The alien environment will impact our bodies and minds in ways we are only beginning to understand. Mars's gravity is about 38% of Earth's. Astronauts living in microgravity environments like the International Space Station suffer from muscle loss, bone density reduction, and cardiovascular changes after just months. How long-term exposure to Martian gravity will affect humans, especially children born on Mars, is unknown. Artificial gravity solutions may be necessary but are complex to implement. Radiation exposure is a major concern. Mars lacks Earth's protective magnetic field, leaving its surface exposed to cosmic rays and solar flares that increase cancer risk and can damage the nervous system. Shielded habitats, underground or covered with regolith, are vital for protecting settlers. Psychological challenges loom large as well. Mars is isolated and barren, with communication delays up to 22 minutes one way to Earth. Isolation, confinement, and separation from family could lead to anxiety, depression, and interpersonal conflicts. Mental health support, social cohesion, and strong community bonds will be essential. Selecting and training crews to withstand stress and work cooperatively will be critical for success. Developing routines, leisure activities, and meaningful work will help maintain morale. Adapting to Mars demands that humans evolve both physically and mentally to thrive in an alien world. Establishing a colony on Mars means more than survival. It involves building a new society with its own culture, laws, and ways of life. Mars has no indigenous population or established borders, so early settlers face the unique opportunity and challenge of creating society from scratch. They will bring Earth's diverse cultures and laws, but these will likely evolve under Mars's unique conditions. A Martian sol lasts about 24.6 hours, slightly longer than Earth's day. Seasons are nearly twice as long due to Mars' elliptical orbit. Governance poses complex questions. The Outer Space Treaty bans national sovereignty claims on Mars, leaving unresolved issues of legal jurisdiction and governance. Will colonies be governed democratically? Will Earth governments maintain control, or will Martian settlers eventually seek independence? Cultural identity will evolve too. Art, music, language, and food will adapt to Mars's environment and lifestyle. Communication delays with Earth might inspire new storytelling and media forms. Children born on Mars may develop distinct cultural traits and perspectives, gradually forming a unique Martian identity. Daily life will reflect these changes, from social customs to leisure and community building. Over time, Mars won't just be a place to live, it will be a new world with its own culture and spirit. Humanity's vision of colonizing Mars is rapidly moving from science fiction toward reality. Near-future missions will focus on developing habitats, producing food, and generating fuel locally, key steps toward independence from Earth. Robotic precursors will scout landing sites, gather resources, and test technology before humans arrive. In-situ resource utilization minimizes reliance on Earth by using Martian soil, ice, and atmosphere for construction, oxygen, and water. Advanced life support systems, energy production, and radiation shielding are evolving fast. Solar panels will harvest Mars' weaker sunlight, while nuclear reactors provide steady power even during dust storms or night. As colonies expand, governance structures, social systems, and cultural institutions will emerge. Mars could become a hub for scientific research, mining, and deeper space exploration. International cooperation, private companies, and technological innovation accelerate progress. Robotics, artificial intelligence, and sustainable agriculture are making living and working on Mars safer and more efficient. Colonizing Mars embodies humanity's spirit of exploration, pushing boundaries to build a new home and extend civilization's reach beyond Earth. Mars is the most promising candidate for humanity's second home. In the coming decades, explorers, scientists, and engineers may establish the first permanent settlements. Initially dependent on Earth for supplies, colonies will strive for self-sufficiency by mining local resources, 3D printing buildings, and growing food hydroponically. Over time, small outposts could grow into interconnected towns with pressurized tunnels and radiation-shielded habitats. Children born on Mars may never see Earth, developing unique cultural identities and perspectives shaped by life under red skies. This new civilization will create new traditions, laws, and social norms adapted to Martian realities. Challenges remain: technical, environmental, and ethical. But the drive to explore and expand is powerful. Mars captures human curiosity, resilience, and hope. Mars is more than a distant destination. It could be the next great chapter in the human story, our stepping stone into the cosmos. Thanks for watching. If you enjoyed this video, don't forget to like, comment, and subscribe. There's so much more to explore together. Stay curious and we'll see you in the next adventure.